Okay, guys. So last time we completed RIP passive interface in our last class. Today we are starting from another RIP protocol process or RIP protocol routing, you can say, and that is RIP version 2 default network routing. Okay, so how to configure this default network routing and why we need this default routing. Okay, so let's have the network first, and then I'll explain you what is the need of this. So, so first we are going to design this network. So you can say RIP default routing. See, normally when we understand this, okay. So guys, as we are discussing about RIP version 2 default network routing and how this default network routing works, we can see this one. So now when we talk about default routing, so before this default routing, we have already configured some RIP routing. So let's configure the scenario, then we will understand why we need this default routing. So let's come here with the router. So here, as per scenario, as per our lab, we need 3 routers and 6 desktop and 3 switches. Okay, 3 number of nodes, and then we'll take some switches, 3 switches as well. Okay, and then we need some computers, like 6 computers. So our router 1 is here, router 2 is here, and router 3 is here. Okay, so now switches, we will be connecting to routers. So these are the, like every time you have to, why I'm taking time to make labs. So while when you want to do practice, you can also make labs like me. That's why I used to record my labs. Change host name, so I can write here switch 2, switch 1, switch 3. Fine. Come here. This is our switch 1. Switch 3. Switch 1 will be with router 1, and now router 1 will have 2 computers. Switch 2 will be with router 2. Switch 3 with router 3. 2 computers and 2 computers. Router 2, router 1, router 3. So now part of connectivity, you can see that from switch to PC we need Ethernet cable. and from switch to router we need Ethernet cable. From router to router you have option whether you need serial or you need Ethernet, so no problem, you can use serial. Okay, so PC3 will connect to switch 2. You can design something different. Serial 2 to serial.
Alonso, yes.
Yes. Okay, so here our lab is ready now. So what we did, we connected the routers, and according to lab now we are taking the network slash 30. So here we are using slash 30. Here we will be using 12 slash 13 slash 30, and then here we will be using 23 slash 30. 25. Okay, and here these all LAN networks they are using here for the LAN connectivity. They are using 192.168.10.0 slash 24. Here this side this router is using for LAN 30.0 slash 24, and this R2 network they are using slash 2024. Okay, so now let's start all the devices, and before starting let's have the console like the port information, that which port is connecting towards which router. See, in the beginning of the class I told you that maybe suppose right now I'm bringing like this, so maybe someone has did mistake like this. Okay, so you will have if you will start configuring with the wrong information, so your lab will not work. So before configuring your network or lab, you just put your mouse on this cable, so automatically you will know that, okay, see here, link from R1 port serial 2 by 2 to R3 port serial 2 by 2 means this port is wrong, so you just bring it here. Even if you'll check here, see here, link from R1 port serial 2 by 0 to R2 port serial 2 by 0 means this is correct. Okay, so whenever you want to verify, you check before configuring it. Okay, otherwise if you'll configure with wrong information, wrong details, then you'll have or your connectivity will not work. Okay, so I'm just removing this unnecessary or like these port numbers, which is not required. Okay, so our lab is ready. Now we are going to start this lab. Lab started. Now we'll take the console of the labs. Now if you are coming to our PC1, okay, let's come to PC1, configure IP address 192.168.10.1 /24, and the default gateway is 10.10, which is our router interface IP address. And this interface IP address will be 10.10. Okay, here 10.10, here this interface 20.10, and here this interface 30.10. Save the configuration. Okay, PC12, which belongs to 10 network, is completed. Now I'm coming to router 1. Conf t, okay, IP interface serial 2/0 IP address 12.1.1.1. Fine. Then type no shut, exit. So one interface is completed, which is serial 2/0. Now we are coming here, interface serial 2/2 IP address 13.1.1.1. No shut, then again exit. Now come here, interface E0/0 IP address 192.168.10.10, and the subnet mask is /24, so it is 0 like that. And no shut and exit, and then you save it. Save, and then you write this command: so IP interface brief exclude unassigned. So you can see here the port IP is configured. Status is down, so no worry. Let's configure all the routers. Then you'll see this status will come up. Okay, protocol will come up. So PC1 IP completed. So we see the lab. Whenever you configure any lab, so now I told you in the beginning of the class of this network security, whenever you configure any lab, so the first requirement is connectivity. Okay, once the connectivity is completed, then IP address configuration. So after that you have to configure IP address on all the devices. Then the third process will come, routing. Okay, so connectivity is already completed. Here you can see the cables are connected with the devices, and now we are talking about IP address configuration. So see here, so PC1 IP completed, PC2 completed, router 1 is completed. Now we are coming to PC3 IP 192.168. Which belongs to 20 network, so 20.1/24, and the gateway is 20.10. Okay, now we are coming to PC3 IP is this one, and then save. Okay, now we are coming to router 2, conf t interface E0/0 IP address 192.168.20.10, and the subnet mask is /24. So interface is okay now with this router 2. Now router 2 has other two interface. Let's configure those interface serial 2/0 IP address 12.1.1.2 and the /30 subnet mask no shut exit. Okay, now come here with the serial 2/1 IP address 23.1 no shut exit. All IP is done. So IP interface brief exclude unassigned. Fine, everything is okay now. Now we are moving to R3. Conft interface E0/0 IP address is 192.168.30.10 interface serial 2/1 IP address 23.2 interface serial 2/2 IP address 13.2. No shut, and then you can save it, and then show IP interface brief exclude unassigned. So everything is okay. Now let me brief here little bit regarding IP address. So here on this interface I'm using 12.1, so I'm just writing .1. Okay, let me here I'm using .1. Here I'm using .2. Okay, here I'm using .1. Instead of red, let me make it green. Okay, now let's make it, so here I'm using .2, here I'm using .2, and here I'm using .1. Okay, .1 here, .2. Okay, now here I'm using .10, which is regarding that network 192.168.10.10. Here I'm using 30.10, and here I'm using 20.10. So IP network is completed. Okay, and we have verified also. If you will come here, okay, 5 and 6 is remaining. Okay, no problem. So come here, IP 192.168.30.1/24 192.168.30.10. Now come here to PC6 and then save it. So all the configuration is completed. Now the part is routing. So before routing, let's come to PC1. Now PC1, which belongs to 10 network, want to communicate to different networks like ping 192.168.20.2 computer or 20.1 computer. See, destination host unreachable, but when PC1 wants to communicate to the same network computer, so let's see here 192.168.10.2, yes, same network computer, yes, PC1 is communicating, but when PC1 wants to communicate to other computer networks, it won't be able to communicate right now, right? Why? Because when the packet is coming to router 1, okay, and router 1 is checking show IP route. See, router 1 is not getting any kind of route information or network information regarding 20. See, okay, see, it has only 10 network, no 20, no 30. So when any packet which is coming from PC1 towards any other network except 10, 30.1c destination host unreachable. So for that you have option for routing. So already we know about this routing. So either you configure static routing or you configure default routing or you configure dynamic routing. So in dynamic we are talking about right now RIP. Okay, so either you configure RIP 1 or 2. So we cannot configure RIP version 1 because it's the network is related to classless network. IP is classless IPs. So we have option RIP2. But when we are configuring RIP2, right, how we configure normally, we configure like this. We come here to router, then we type here, suppose if we are on router 1, okay, we normally type here router RIP, okay, then we type here version 2, then we type here network and the connected network. So maybe if I'm on router 1, we will write like this, okay, okay. So we'll write like 12, 13 and 192.168.10.0 like this, and then we write here no auto summary, right? So we write like these informations. But what I am saying here, we write the connected network informations, right? But when we are configuring default routing, default network routing with the help of RIP, okay, we just normally write like this. We just write here, we can copy this one, okay. So here we just write network 0000, that's it. Now no need to write these things. Okay, now you will say what is the benefit in this. So if you configure any routing, either this routing or either this routing, all the routers will communicate and all the systems will communicate with the help of this RIP routing. But what is the benefit in this? Okay, so the benefit of configuring default network routing, like in future if you will add any network on router 1 or maybe router 2 or router 3, automatically it will be advertised in RIP and it will start communicating. But if you will configure this routing what we are talking here, RIP, this with the network information, so whenever you will add any network or if any network will go down, you have to remove those networks manually from the router RIP command. Okay, but here in this everything is automatic. Once you advertise it, whenever you add any network, automatically those networks will be advertised in RIP network, or whenever you will remove that network, automatically those networks will be removed. Okay, so in some condition this is beneficial, okay, but in some condition it's not good when it is connected in the public network. Okay, so here we have to know about how to configure default routing. So let's come here to router 1 and it's very simple. Come here conf t router RIP version 2 network and just no. exit. Same thing, you come here to router 2, conf t router rip version 2 network no auto. Okay, now let's come to router 3, conf t router rip version 2 network no auto exit. So your routing is configured. Now if you'll come on router 1 and check the routing table, so IP route, you'll see that yes, all the routes is with you now. Okay, so you can get all the routes. Now you see you are on router 1. Okay, now you are getting 20, 30 also with you. So now when this PC wants to communicate to those networks, now see easily they are communicating. Now maybe what I told you, in future, okay, in future if R1 will connect some network like loopback 1 1.1.1.1/32. So it added one network here. So if you'll come here, conf t, okay, before that I would like to show you some routing table of R3. So IP route rip. So see here, R3 doesn't have related networks, right, regarding 1. But when you will come on R1, interface E0 by loopback 1 IP address 1.1.1.1, and now if you'll check, just come to R3 and you'll see that, see, one network is here. So here whenever you are removing, okay, and suppose if you will remove this network, okay, maybe if I'm coming here on this interface loopback 1, I'll say no, I just want to remove that loopback. So when you have removed, you come here, see that what network 1 is not there now. So this is the benefit of this default routing concepts. Okay, now we are talking about RIP manual neighborship. Okay, so why we need this RIP manual neighborship and in which condition we need? Suppose we have some network here. Suppose this is our company router. Okay, now what happened when this PC wants to communicate to branch? Maybe you have a company which has multiple branches. So this is your headquarter, your company headquarter, you can see. Okay, this is your headquarter, and these are some branch 1 and branch 2. Okay, now when these PC want to communicate to branch, so for communicating with branch you need ISP in the middle, because ISP will help you to create communication between branch. Okay, so when ISP is there in the middle, so maybe if you are configuring RIP, okay, so first what you have to do, first you configure RIP and see the problems, then I will tell you with the help of RIP manual neighborship you can remove those type of problems. Okay, so we are going to configure normal RIP routing now. RIP manual neighborship. So here we are going to configure RIP manual neighborship. RIP manual neighborship. Okay. So in this RIP manual neighborship, we have to follow the labs. So here we need four routers. Okay, 5 router, 4 PCs. Okay, so we can take here 5 routers and one switch, and we can take 2 computers also. It's not, we don't need like. Okay, switch 1 with the PCs. Okay, so here we are changing the name of this device. So we'll say here this is our headquarter router. This is ISP, so we'll change the symbol to ISP. Okay, this is our branch 1, NS branch 1. This is our NS branch 2, and this is man in the middle. You can say this is a hacker. So come here, select hacker system icon. Okay, so this is hacker. See why it is hack. We are putting this hacker because see, you'll find hacker in internet, right? So whenever your branch are connected with the help of ISP, so hacker is also connected with ISP, right? Okay, so now we are talking about connectivity E0 by 0 to 0, E0 by 1 to 1, E0 by 2 to 2, and here E0 by 3 to 3. So we are going to join with some network. Okay, so here as same we are using here 12.1.1.0 slash 29 network. Okay, here what we can do, here we need see normally what ISP, I here ISP use one kind of frame relay switch. ISP use one frame relay switch. Okay, so right now we do not have frame relay switch, so what I can do here, let me delete it. Okay, we can have this normal switch. Okay, and we'll change it to frame. Okay, because this is a lab, so we cannot have frame relay switch. Okay, but this is the part of ISP. So normally what frame relay switch. Okay, with ISP. Now we can connect it E0 by 0 to this, E1 to E1, E2. So these are port numbers on the interface, and these port numbers will help us to configure the interface IP. Okay, so we can come here, we should write that here you are using 10.0/24. Here we are using, which is already there, /29 IP address. Now your branch is using one network, loopback 1 2.2.2.2/32. Hacker is using one network 4.4.4./32. Your branch 2 is using 3.3.3.3. Fine. And here you this headquarter using one network. Okay, fine. So now we are going to configure RIP version 2. Okay, so let me configure normal RIP, then we'll see the problem and then we will solve the problem with the help of manual neighborship. Okay, so start all the devices. Take a console. PC1, PC2, then headquarter, then hacker. So let's come to PC1, IP 192.168.10.1/24. 2/24. The gateway is 192.168.10.10. Save it. PC2 IP 192.168.10.2/24 and the gateway is 10.10. Okay, now we are coming to our headquarter router. Conf t interface E0/1 IP address 192.168.10.10. No shut. Okay, so let me write it again here. So here we are using 12.1 IP. Here we are using .2. Here we are using .3. And here we are using .4. And here we are using 10.10. Okay, so E0/1 is completed. Now we'll type here interface serial interface E0/0 IP address 12.1.1.1 /29 is 248. No shut, and then we can save the IP configuration. Okay, one more IP is remaining. Interface loopback 1 IP address 1.1.1.1. Save it. So IP interface brief exclude this. So IP interface, yes, IP is okay. Now we'll come to our branch router. Interface E0/1 IP address is 12.1.1.2 248. No shut. Okay, and then interface okay, so we'll come here to the interface loopback 1 IP address 2.2.2.2. I mean it is /32, that's why I'm using that subnet. Exit, save. Conf t interface branch 2 interface E0/3. Let's come here to branch 1. Did I configure it correct? Yes. Okay. IP address 12.1.1.3 248. No shut. Interface loopback 1 IP address and then save it. Now hacker also, let's configure the hacker system. Interface loopback 1 IP address then interface E0/2 IP address 12.1.1.4 248 no shut. And what hacker will do, see, hacker always ready for routing. So hacker will do some kind of default routing, router RIP version 2 network. Okay, so hacker has configured its routing. Okay, so hacker will save the routing. Okay, now what I'm coming, let's come to your headquarter and configure RIP version 2 routing. So conf t router RIP version 2 network. You will say, okay, let's configure network 192.168.10.0. You have three network, 1.1.1.1 and one more network which is 12.1.1.0. no auto. Fine, let's come here to branch 1. Conf t router RIP version 2 network 2.2.2.2 and one more network is 12.1.1.0. then no auto. Fine, come to branch 2. Conf t router RIP version 2 network and then one more network which is 12.2. Your directly connected network should be advertised here. Okay, auto, everything is fine. Now if you'll come on headquarter router, and these headquarter PCs now they will be able to ping with the branch. Yes, why? Because of routing. See, your headquarter branch computers are now pinging to branch computers. Okay, so headquarter computers are now communicating to branch computers 2 as well as 3. Okay, means from here these computers are now able to communicate to branch computers. Okay, even branch also ping 192.168.10.1, they are also able to communicate to your headquarter computers. No problem. Now what the problem will come, if hacker will come, and now see hacker, what hacker is doing. If hacker is also coming and trying to communicate to your headquarter computer, see, hackers are also able to communicate, means there is no any kind of security, right? Now anyone can come and connect to ISP and run RIP, automatically they will be your neighbor. And now if you are coming here to your headquarter router and checking here, so IP route, see here you have a neighborship with hacker router, right? So resolving those problems, if you want to resolve those problems, you have to run some kind of neighborship, manual neighborship, not automatic neighborship. So here what is happening, here your router is forming some kind of automatic neighborship, means here, so IP protocols. Okay, see, you're getting the neighborship with hacker router automatically, and these are automatic, you're not configuring like that, okay, I should be neighbor with that branch 1, branch 2 or like that, right? So what you have to do, you have to create some kind of manual neighborship, or you can say personal neighborship configuration. So those are manual, not automatic. Okay, so what here we are getting, these are automatic configuration, what we have done right now. So for configuring manual neighborship, okay, so there are some conditions. First understand the conditions here. Let me write the condition. So condition number 1, okay, condition number 1 means, like, NS headquarter router neighborship with neighborship with NS branch 1 router. Okay, again you will say that NS headquarter router forming neighborship with NS branch 2 router manual. Okay, and vice versa, means branch 1 will have neighbor with headquarter and like that. Okay, like this. But right now if you're coming here and checking that everyone is neighbor with, okay, and now you have to say that third condition note, make sure that NS branch 1 router will not be neighbor of NS BR2 router. Okay, means branch neighborship will be this, like headquarter to branch 1, headquarter to branch 2, no direct neighborship. Okay, means branch 1 cannot be neighbor of branch 2. So these are conditions, and now for fulfilling those conditions, see how we are configuring. So now we'll come here, come to headquarter, conf t, then first you remove it, no router rip. Remove this router rip configuration from all your routers except hacker router. And once it is done, now if you're coming on your router to check, so IP route, no routes, and so IP protocol. Okay, nothing is running now. So now we are configuring it. So let's come here to headquarter router, conf t, router rip version 2 neighbor. So here you have to write your neighbor address. So my neighbor router address is this one. Then again I have one neighbor which is 12.3. Okay, and then you have to configure here network. So network is, yes, I belongs to 12.0.0 this network, and I have one more network, and then I have one more network, 192.168.10.0, and then you write here no auto and write one more command, passive interface E0/1, and then no auto. Fine, configuration is completed. Now you come here to your branch router, type here router rip version 2 neighbor with 12.1.1.1 network 2.2.2.2 network 12.1.1.0 no auto. Fine. Now come here to branch 2 conf t router RIP version 2 neighbor 12.1.1.1 network 3.3.3.3 network 12.1.1.0 no auto. Fine, everything is okay. Now if you are coming on your headquarter, now if you are checking here, show IP route, yes, you have routes. Okay, yes, you are getting your hacker routes also, no problem, but hacker show IP routes. Okay, hacker is also getting routes, but when if you'll refresh it, because see it's going to okay, after some time you can see here the network is down. Okay, after some time the network will go off. So for this what we can write here, clear IP route star, and now let's check whether it has a routing table or not. Okay, now see no routing table. If you check here, now your router is not getting any kind of routes, hacker route. And if hacker router is now trying to communicate to anyone, no communication. Even hacker is running your okay, now is okay, it's getting some update. One second. Okay guys, so now you have seen here that normally if you will come here, so IP route, we have configured manual neighborship and still we are getting updates. So what you have to do, you have to come and you have to stop broadcasting.
Oh, okay.
Okay, please mute yourself so we can. Okay. So normally how we have to stop broadcasting multicasting, because you can see here that if you are running here debug IP RIP. So if you see here, it is multicasting on 224009. Okay, you can see here it is multicasting on 22409. So we have to stop this multicasting. Okay, so how to stop this multicasting? We come here conf t router RIP version 2 passive interface f0 by 0, and this we have to run all the routers. So I forget at that time to enable passive on that interface. So what we'll do, we'll come to all the routers, which is our headquarter and branch routers. We'll come here conf t, and then we'll come here router RIP version 2, and we'll enable the passive interface on that interface which is connecting to ISP. So they will not be multicasting, they will be only unicasting. So here you can say router RIP version 2 configuration is completed. And now if you're coming to the headquarter router and if you're running here debug IP RIP, just wait for the update. See, they will be receiving update on a specific IP address. Now if you're coming on the hacker system, clear IP route star, and now if you're checking here, so IP route, see, no routes, right? And now PC1 will easily communicate to 2.2.2, and the headquarter computer and 3.3.3. Okay, now one more problem is here, but I'll have to explain you. Okay, now what we are saying here, show IP route. So if you're coming here, see, headquarter router is getting all the routes from branch 2 as well as 3, right? And if you're coming here to the branch routers, and if you're coming here and checking here, show IP route, see, clear IP route star, clear IP route star. And now if you're checking the show IP route, see, branch is getting routes from headquarter, but not, see, what is problem is, see, this branch 2 is sending update to headquarter, okay, and this branch 1 is sending update to headquarter. So here headquarter is getting all the updates, but what headquarter is saying, headquarter is not exchanging those updates like this. Okay, it's not exchanging updates, and due to the problem of split horizon rule. Is what is split horizon says, that whatever update your interface is receiving, that same update, the same interface will not be transmitted over the network. Okay, so if you come here and see this passive split horizon rule. Okay, what the split horizon rule is, a loop avoidance technology. Split horizon rule is one of the method used by distance vector routing protocol to avoid routing loops. The split horizon rule is very simple. A router will not advertise a route back to the same interface on which it has learned. Okay, so we have to come to router 1. It's very simple. The last command here, interface fa0/0. See, just write no IP split horizon. That's it. And once you will run this command, now you will come to here. See, so IP route, you will get route. Okay. And now if you're coming here, branch, so IP route. Okay. See, you got the update here. Your branch is getting branch 2 is getting update from branch 1, and branch 1 is also getting update from branch. But if you'll come to hacker will not get any kind of information here. Okay, so this is the benefit of this uh, manual neighborship. And basically manual neighborship is formed when we configure some kind of branch communications. Okay, so this lab is for you, you should configure it. And in the next class we will be talking about this RIP default propagation network